Hello everyone, welcome to Brain Blitz Audios. Today in this episode of JEE Main, we're going to be looking at previous year questions of mathematics asked in engineering entrance exams in India. Today we're dealing with a very important chapter in mathematics. The name of this chapter is Matrices and Determinants. So this deals with the arrangement of numbers in a row and column, which we call as a matrix, and operations on matrices as well as their determinants. So today let's look at our first question. Now here it shows you the matrix A being 1 minus 1 1, 2 1 minus 3 1 1 1. So we'll consider this as the matrix A, and we'll consider the matrix 10 times B as 4 2 2 minus 5 0 alpha 1 minus 2 3. Now if B is the inverse of the matrix A, then alpha is equal to. So we're going to be focusing on this point first. B is the inverse of matrix A. So what does that mean? It means B is equal to the inverse of matrix A, which we'll write it as A inverse. So if B is equal to A inverse, then by multiplying 10 on both sides, you can write 10B as equal to 10A inverse. Now you know the value of 10B. The value of 10B is 4 2 2 minus 5 0 alpha 1 minus 2 3. This is equal to 10 times A inverse. Now what conversions can we do further in order to make this in the terms of A? Well, what you can do is you can post multiply by the matrix A on both sides. So what do you get? 4 2 2 minus 5 0 alpha 1 minus 2 3 times the matrix A equals 10 times the matrix A inverse times the matrix A. A inverse times A gives you the identity matrix I. So therefore 10 times I will be equal to 10 0 0 0 10 0 0 0 10, and we'll put in the value of the matrix A as well. So the expression now becomes the matrix 4 2 2 minus 5 0 alpha 1 minus 2 3 multiplied by the matrix A, which is 1 minus 1 1 2 1 minus 3 1 1 1. The right hand side being equal to the matrix 10 0 0 0 10 0 0 0 10. Now we have to do matrix multiplication on the left hand side, and then the matrix that we get on the left hand side will be equal to the right hand side, and from there we can find the value of alpha. So when you're doing matrix multiplication, the basic thing to remember is that the row of the left matrix is multiplied with the column of the right matrix. So first row times first column gives you first element, first row times second column gives you second element, first row times third column gives you the third element. Then you'll do the same with the second row and then with the third row. So that's how you get the product of the two matrices. So let's do it. So 4 2 2 times 1 2 1, that will be equal to 4 times 1 plus 2 times 2 plus 2 times 1. This is one element. The next element will be 4 times minus 1 plus 2 times 1 plus 2 times 1. And then the third element of that row will be 4 times 1 plus 2 times minus 3 plus 2 times 1. So now let's move on to the second row. In the second row, we multiply the second row of the first matrix with each of the three columns. So when we do that, we will get minus 5 times 1 plus 0 times 2 plus alpha times 1. That is the first element. The second element will be minus 5 times minus 1 plus 0 times 1 plus alpha times 1. And then the third element will be minus 5 into 1 plus 0 times minus 3 plus alpha times 1. Now we'll move on to the third row. Again, here we multiply the third row of the first matrix with each of the 3 columns. So when we do that, you get 1 times 1 plus minus 2 times 2 plus 3 times 1. That is your first element. The second element will be 1 times minus 1 plus minus 2 times 1 plus 3 times 1. And then the final element, that will be 1 times 1 plus minus 2 times minus 3 plus 3 times of 1. So now we'll simplify this. 4 times 1 is 4 plus, so this is 4, this is 4, that is 2. 4 plus 2 gives you 10. And then minus 4 plus 2 plus 2, so that is minus 4 plus 4 gives you 0. 4 minus 6 plus 2, 4 plus 2 gives you 6. 6 minus 6 is once again 0. Now when we move on to the second row, it'll be minus 5 plus 0 plus alpha. So minus 5 plus alpha is the first element. Minus 5 times minus 1 is 5. 0 times something, anything is 0. Alpha times 1 is alpha. So the middle term is 5 plus alpha. And the third element will be minus 5 times 1, that is minus alpha, plus 0 times anything is 0, plus alpha times 1 is alpha. So here in the last row, we have 1 minus 4 plus 3. 1 plus 3 is 4. 4 minus 4 is 0. Again, 1 times minus 1 is minus 1. Minus 1 plus minus 2 gives you minus 3. Minus 3 plus 3 gives you 0. Here you have 1 times 1 is 1. 3 times 1 is 3. So 4 plus minus 2 times minus 3 gives you 6. So 4 plus 6 is equal to 10. And on the right hand side, you have 10i, which is equal to 10, 0, 0, 0, 10, 0, 0, 0, 10. So as you can see here, the matrix on the left must have the same elements as the matrix on the right. So that means minus 5 plus alpha has to be equal to 0, and 5 plus alpha has to be equal to 10. Minus 5 plus alpha is equal to 0, so therefore alpha is equal to 5. Or you can write 5 plus alpha is equal to 10, so therefore alpha is equal to 10 minus 5, which is equal to 5. So therefore the final answer in both cases is alpha is equal to 5. So therefore, in this question asked in 2004, option D, 5, is the correct answer for the value of alpha if you have the following two matrices given, and it is said that B is the inverse of the matrix A. Now let's look at the next question. In this question, it is said that the series A1, A2, A3 until an and then moving on till infinity, it is a geometric progression. Then you need to find the value of the determinant log an plus 1, log an plus 2, log an plus 3, log an plus 4, log an plus 5, log an plus 6, log an plus 7, log an plus 8. So over here, we're given that the series is a geometric progression. So it is from here that we first start solving the question. Now, in a geometric progression, if you take 3 consecutive terms, so we can take any 3 consecutive terms, but for our calculation's sake, in the determinant, we can take an plus 1, and an plus 2. So over here it's an plus 1, an plus 2. And then according to the property of the geometric progression, the square of the middle term will be equal to the product of the first and the last term. So that means an plus 1 the whole square equals an times an plus 2. So now what we do, we take log on both sides. So therefore you get log an plus 1 the whole square equals log of an times an plus 2. So now we use the property of logarithms. So we can use two properties here. Log a raised to n gives you n log a, and log ab gives you log a plus log b. So when we apply that, the equation now becomes 2 log an plus 1 equals log an plus log an plus 2. So on rearranging this, so by rearranging, we take 2 log an plus 1 to the right hand side. So that means log an plus log an plus 2 minus 2 log an plus 1 is equal to 0. This we can consider as equation 1. So similarly, we can take other triplet combinations, 3 consecutive combinations. So here we can take an plus 3, an plus 4, and an plus 5. These are consecutive. And an plus 6, an plus 7, and an plus 8. These are also consecutive. So similarly, taking an plus 3, an plus 4, an plus 5, and an plus 6, an plus 7, as well as an plus 8. So we can write two more equations of a similar pattern. We can write log an plus 3 plus log an plus 5 minus 2 log an plus 4 as equal to 0, using the property of the geometric progression. We can also write log an plus 6 plus log an plus 8 minus 2 log an plus 7 as also equal to 0. We'll consider these two equations as equation 2 and equation 3 respectively. Now, why are we taking these three equations? You will see that when we look at the determinant. So over here, the value of the determinant is log an plus 1, log an plus 2, log an plus 3, log an plus 4, log an plus 5. You can see the similarity that we find. So over here, if you take a rearrangement, then you can make a whole column 0. That's the point. So log an plus 6, log an plus 7, log an plus 8. So if you look at our three equations, you can see that over here you can convert column 1 into column 1 plus column 3 minus 2 times column 2. So we will convert C1 to C1 plus C3 minus 2C2. And when we do that, we get 0, 0, 0, log an plus 1, log an plus 4, log an plus 7, log an plus 2, log an plus 5, log an plus 8. So now what we could do is we can just expand along C1, expand along column 1 in order to find the value of the determinant. Now we don't need to do the expansion because we know that when you take the terms along C1, you will find that all of the permutations and combinations along the expansion will have a 0 multiplied to it. So therefore, the determinant will automatically become 0. So the right answer for the value of the determinant is option C, 0. That is the correct option for this question, asked again in 2004. Now, let's look at this question. So here we have an equation, a squared minus a plus I equals 0. Then you need to find the inverse of a. So here A is any matrix, and I is the identity matrix of, say, that same order. So how do we find the inverse of A? Well, it's pretty easy. A squared minus a plus I equals 0. We'll just rearrange this to have I on the left-hand side, and on the right-hand side you get a minus a squared, which is equal to a minus a squared equals a times a. And then what we do is we pre-multiply by the matrix A inverse. So therefore it will be A inverse I equals A inverse A minus A inverse A times A. So A inverse A will give you the identity matrix, and any matrix times the identity matrix will be equal to the same matrix. So A inverse times I equals A inverse times A equals I, minus A inverse times A equals I, and then I times A is equal to A. So therefore, the right answer for the inverse of A is option C, I minus A. So the value of A inverse in this question is the same as the value of the identity matrix minus the matrix A. Next question. If the matrix A is 1, 0, 1, 1, and the matrix I is 1, 0, 0, 1, where I is the identity matrix, then which one of the following holds for all n greater than or equal to 1 by the principle of mathematical induction? So we have 4 of these equations. We need to find out which of these is correct. So first things first, we know that the matrix A is 1, 0, 1, 1. So when we try to square this matrix, which is essentially multiplying it, you will get 1, 0, 1, 1 times 1, 0, 1, 1. So it'll be 1 times 1 plus 0 times 1. And then you have 1 times 0 plus 0 times 1, that is 0. 1 times 1 plus 1 times 1. And then over here, it'll be 1 times 0 plus 1 times 1. So the value of A squared will now be equal to 1, 0, 2, 1. Now similarly, if we take the matrix A cube is just similar to writing A squared times A. Since we know the matrix A squared and the matrix A, it's just a matter of simple matrix multiplication. 1, 0, 2, 1 times 1, 0, 1, 1. So that is equal to 1 times 1 plus 0 times 1. 1 times 0 plus 0 times 1, and then 2 times 1 plus 1 times 1. Then you have 2 times 0 plus 1 times 1. So therefore, the value of a cube will be equal to 1031. So as you can see, a is 1011, a square is 1021, and a cube is 1031. So it makes sense to write a raised to n as equal to 10n1, because we've been writing it for a square, and a cube, so it makes sense to generalize it for any exponent that is n. So we have to write this a raised to n in the terms of the matrix A and the matrix I. So, you know, if you have n and you need to obtain the element 1, then you can just subtract it with n minus 1. So if you take n0, nn, then you can write n minus 1, and then 0, and then n minus 0 will still give you n, and then over here, since it's 1, so you can write n minus 1. So this expression will be the same as the value of a raised to n. Now n0 nn will be the same as writing n times 1011, minus n minus 10, 0, n minus 1 will be the same as writing n minus 1 times 1001. Now you know 1011 is a, and 1001 is I, so therefore the value of a raised to n will be equal to n times a minus n minus 1 times the identity matrix I. So this is the correct expression, and if you look at our question, which is asked in 2005, then you will notice that option B is the correct option. This is a easy way to find out the actual answer for this question. Otherwise, we have to use the principle of mathematical induction, which goes along the standard method. Now we have the final question of this episode. It says the system of equations ax plus y, alpha x plus y plus z equals alpha minus 1, x plus alpha y plus z equals alpha minus 1, x plus y plus alpha z equals alpha minus 1. That is, these three equations are a system. Now it says that this system of equations has no solution if alpha is either minus 2 or 1, minus 2, 1, or not minus 2. So we need to find out which of these options is correct with respect to the value of alpha if the system of equations have no solutions. So first we'll write down the general condition. For a system of equations to have no solution, you can note that the determinant of A will be equal to 0, and the product of adjoint of A times the matrix B is not equal to 0. So let's try and find out the value of alpha. So we have the system of equations. You have equation 1, equation 2, and equation 3. So when you represent them in the matrix form, you will get alpha 1, 1, 1 alpha 1, 1, 1 alpha as the matrix A, times the matrix B, the matrix X is the variables x, y, z, contains those variables, equal to the matrix B, that is equal to alpha minus 1, alpha minus 1, alpha minus 1. So this is our equation in the matrix. Now remember that we have given the condition that the system of equations does not have a solution. So that means the determinant of A is always equal to 0 in that condition. So since the determinant of A is equal to 0, alpha 1, 1, 1 alpha 1, 1, 1 alpha, so the determinant of this matrix is equal to 0. So when we are expanding it along, say, row 1, you will get alpha times alpha minus 1 times 1 minus 1 times 1 into alpha minus 1 into 1, and then you have plus 1 times 1 into 1 minus 1 into alpha. So this expansion will be equal to 0. So you basically will get a cubic equation here. So alpha times, inside the bracket it will be alpha square minus 1 times alpha minus 1 plus 1 times 1 minus alpha as equal to 0. So therefore you will get alpha cube minus alpha plus 1 minus alpha as equal to 0. So therefore you get alpha cube minus 3 alpha plus 2 as equal to 0. So now what we can do is we can convert this equation as alpha cube minus 4 alpha plus 2 as equal to 0. Then what we do is we add and subtract 2 alpha square. The reason why we're doing all of these steps is to make this simplified. So you have alpha cube plus 2 alpha squared minus 2 alpha squared minus 4 alpha plus 2. So now you can take these so we'll take alpha plus 2 common outside. So basically you have alpha squared times alpha plus 2 minus 2 alpha times alpha plus 2 plus 1 times alpha plus 2. So therefore you get alpha squared minus 2 alpha plus 1 times alpha plus 2 as equal to 0. Now alpha squared minus 2 alpha plus 1 can be written as alpha minus 1 the whole square, and then you have alpha plus 2 as equal to 0. So from this simplification you will get the value of alpha as equal to minus 2 or as equal to 1. So we might think that we've arrived at an answer, either minus 2 or 1. But here the condition is the system of equations should not have any solutions. But determinant of A equals 0 only means that it can have no solutions or that it can have infinite solutions. So we should apply the second condition, that is adjoint of A times B is not equal to 0. When alpha equals 1, the matrix B will now be equal to alpha minus 1, which is 1 minus 1, 1 minus 1, and 1 minus 1. Basically, the matrix B is a 0 matrix. So if you have adjoint of A times B, it will be adjoint of A times 0, which is equal to 0. So when you have alpha equals 1, you will have infinite solutions. So therefore, the right answer is the option where it states that alpha is equal to minus 2. So therefore, the correct option is option B, minus 2. So we have two values of alpha, but we're using the effective condition that determinant of A equals 0 and adjoint of A times B is not equal to 0. So when you put alpha equals -2, adjoint of A times B is not equal to 0, you can try that out. But then it is obvious that option B is the correct option for this question asked in 2005. So that concludes this episode of JEE Main. We hope that you found this episode interesting, especially with complicated problems regarding matrices and determinants. For more of our videos on JEE Main, you can just click the link in the description down below. For getting more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. You can also hit the link in, you can also hit the notifications button that is present below the video to receive latest updates from our channel. So until the next webisode, take care, stay safe, bye-bye for now.